And it's gone. Creating a power supply, an audio amplifier, or for example a constant load is pretty awesome, I would say. And up until now, I either use MOSFETs or BJTs for those jobs. These two types of semiconductor switches are amazing and make our modern electronics world possible. But they're of course not the only type of transistor, because when looking at a distributor website, then we can find quite a few different flavors. And I actually included almost every one of these in previous videos. Except one, the so-called JFET. I feel like these always get overlooked. I mean, truth be told, I have not really used them practically before. But I heard they might be doing an interesting comeback in the near future. So in this video, let's do some experiments and find out whether JFETs are actually useful or a relic of the past. Let's get started! This video is sponsored by Mouser Electronics, who not only offer thousands of electronics components for you to order, but they're also hosting a new memory puzzle game giveaway. If you win, you have the chance to win a Bambu Lab A1 3D printer. So click the link below to check it out. And while you're already at the Mouser website, why not check out some of their newest components? Maybe there is a perfect fit for your next project. Now first off, here we got some guinea pig JFETs, and as you would have guessed, they use pretty much the same packaging as MOSFETs or BJTs. So let's start with a pretty generic and popular JFET, the 2N5458 N-channel JFET, which comes with 3 pins called gate, drain and source. And wait a minute, MOSFETs also come with these 3 exact pins. So do they work the same? With a MOSFET, you would connect source to ground, drain to the load, which in my case is a resistor, and gate to control voltage, which all in all looks like this as a schematic. Now when the gate voltage is 0 volts, then no current flows, and if we increase the gate voltage, more and more current starts flowing through the MOSFET until it is fully open. So if we replace the resistor with an LED strip and inject either 0 volts or 5 volts into the gate, then we can basically use the MOSFET as an electrically controllable switch, which is one of its main applications. And the big question now is whether our JFETs can do the same thing. But before finding that out, I firstly had to shorten the LED strip significantly, because the JFET can only handle small loads. And yeah, nothing really worked like with the MOSFET. At 0 volts, the JFET was already open, and while going slightly higher made the JFET apparently a bit more conductive, there quickly was a worrying gate current flowing that ultimately destroyed my JFET completely. So before doing any more guesswork, let's check the datasheet, and it was pretty quickly obvious what went wrong. You see, a MOSFET is off at 0 volts and turns on more and more with a higher gate voltage. A JFET, however, is turned on at 0 volts and closes, aka becomes less conductive with a more negative voltage applied to its gate. The reason for that is its internal structure, which is normally open, and only if we apply a negative voltage to the gate, this N channel here gets pinched off and eventually lets no current flow from drain to source. So time to apply a negative voltage to the gate, which I can do with a second power supply, whose positive terminal I hook up to ground and its negative terminal to the gate. And this time it does work like expected, and it seems like minus 2.2 volts seems to be the threshold at which no current flows. So we can use a JFET like a switch as well, but let me tell you that using 2 power supplies is very unpractical. With a MOSFET this is much easier, because you can simply build up a voltage divider, since you don't need a negative voltage for the gate. But there is of course an easy solution for the JFET as well, so-called charge pump inverter ICs. This one basically only needs 2 capacitors to work, and thus it converts our plus 5 volts at the supply into -5 volts at the output, which after hooking up to the JFET does its job perfectly fine of turning it off. Here's by the way the schematic if you're curious. But if such an IC is too expensive for your project, then you can also do it super cheap, but not perfect, with only 2 additional resistors, which as you can see it does also work. Here the JFET is used as a high side switch, meaning the load is connected between source and ground. To turn the JFET on and off, we care about the VGS voltage, aka the voltage between gate and source. I tied the gate voltage here to ground, or 0 volts, with a resistor. Now when current flows through the load, then there will be a voltage drop across it, which lifts up the source voltage by this value, meaning now we got -2 volts at VGS, which keeps the JFET almost closed. So when we apply a different voltage to the gate, more current can flow, and the load voltage drop and thus source voltage changes, and kind of like creates a new equilibrium with the gate voltage, with the JFET now open. Yeah, it looks simple, but it is hard to explain. The big disadvantage of this method though is that a little bit of current always have to flow, and thus the load is never really completely turned off. So in conclusion, driving a JFET is not really easy. So does it come with some crazy good advantages that make up for it? Well, firstly the bad news, because after measuring the voltage drop and current flow of my JFET as a switch, it turns out to come with a pretty high resistance in comparison to, for example, a MOSFET. So at first glance, they're actually terrible switches. But here comes the good part. They not only have a high input impedance, which basically means they need almost no current at their gates, unlike BJTs, they also feature a very low input capacitance and low distortions. And for what are these properties important? Of course, all kinds of amplifiers, and that includes audio amplifiers. I mean, this particular JFET here even gets promoted as an audio amp, and this one as a high frequency amplifier. So just for fun, I built up the most basic audio amp with it, whose schematic looks like this. And yeah, even though the volume is pretty low, it sounds pretty decent. For more scientific tests though, I next wanted to measure its total harmonic distortions. And for comparison, my previous MOSFET audio amp achieved a THD around 0.5%, while my BJT circuit achieved around 0.25%. And it seems like the JFET is even better than that, with just below 0.2%. Not bad at all. And that is not all, because by simply adding just one potentiometer to a JFET, you can easily turn it into a constant current sink. That means no matter how I change the voltage here, the flowing current stays pretty constant. I mean, I can even increase the number of LEDs or short them all out, the current stays the same. And of course, we can adjust the current with the potentiometer, whose changing resistance once again creates a changing voltage drop here that lifts up the source voltage. It's basically the same trick from before. And last but not least, we can easily use a JFET as a variable resistor in a voltage divider, and thus turn our 12 volt input voltage into a lower one. This is a bit more tricky though, because this time you really have to apply negative voltages. But it is really useful when you, for example, want to lower an audio signal or similar. So these were 3 examples where JFETs with their properties are truly useful. But technology constantly evolves, and thus we nowadays also got these SiC JFETs, aka silicon carbide JFETs. These truly are great switches, because they not only come with a super low resistance, but also no freewheeling diode, which can sometimes be a hassle when working with MOSFETs. That is one of the reasons they're currently becoming more and more popular, and I might do a follow-up video on them specifically when the time is right. Until then, I hope you now got a basic understanding about JFETs, and understand why you don't see them that often, but they're still important for certain applications. As always, thanks for watching. Don't forget to like, share, subscribe, and hit the notification bell. Stay creative, and I will see you next time.